you guys up too much. Thanks for coming to Tech Ed. Thanks for coming to this session. I know being the 5 p.m. session on the third day, you're probably all struggling with a little bit of information overload, a little bit of soreness in your feet. This place is rather large. It's a good thing that they're shoving us all full of candy and chocolate and coffee. Just making that walk back and forth between buildings B and C is pretty intense. But actually, seriously, I want to thank you, more importantly, for your support of the Windows Phone platform. I've had a lot of interesting conversations this week that go something like this. I'm, wearing this shirt around, and so people see, I'm on the Windows Phone team. So, like, hey, you on the Windows Phone team? Yes, I am. So, when are you guys adding full device encryption? Where's the Bluetooth API? Where's the private marketplace? There's a laundry list of features that are missing, and so I understand this. Try to prepare my best answer about features and priorities and scope and how we're behind in the consumer market. We need to catch up there first. And before I even get that out of my mouth, I have people saying, you know what? I love this thing. I really love this phone. I love what you guys have done with it. It's a fantastic user experience. And so even though my clients are telling me I can't deploy this into my enterprise, I'm missing features that I need to be able to have applications on Windows Phone. As a user, I love it. And so I'm pushing back against my clients and trying to think about workarounds for how we can avoid certain requirements or change the scope of certain requirements to be able to write applications for Windows Phone and ship them into the enterprise. And that's fantastic. The other flavor of that conversation is people saying, hey, I go into the AT&T store and I challenge them and say, how many Windows Phones do you have here? Are you trying to sell them? How are you comparing Windows Phone against Android and iPhone? And so that level of passion from our developer and just end user community is fantastic. And so the good news I have for you is that one of those features that we would have had the conversation about last year of where is feature X, namely a database, we're solving in Mango. And so I'm going to talk through that today, as well as a couple other things. My name is Sean McKenna. I'm a program manager on the Windows Phone application platform team. So our team builds the framework and tools for all of you to write applications to run on Windows Phone. Before we get started, though, I need to make an announcement. If you've been to any of the other Windows Phone sessions, you'll know that you have a chance to actually win a Windows Phone. How many people have a Windows Phone in the room, by the way? Okay, probably about 3/4. So the other 25% of you, you've got a chance to win a Windows Phone. So pay attention, because there will be a quiz at the end. Normally people say that jokingly, but actually there will be. So I'm going to talk about two topics. The first one I think is probably the most interesting for this audience is that we're adding a database to the phone. And I'm going to talk through the details of that and how you set it up. But there's another sort of aspect to our data support that we're adding in Mango, which is that we're giving you access to the contacts and calendar information on the device. And so you can use that to light up some interesting user experiences for your applications. So how many people in here are familiar with Lync? Almost everybody. OK, fantastic. So as you know then, Lync is this general purpose way of querying collections in .NET languages. And so you can query all different types of data sets. And we decided early on with Windows Phone, when we were building the application platform, that we were going to bet on Lync. I mean, clearly, we're taking a bet on Silverlight and XNA, key .NET frameworks, and so we're going to go with Lync as sort of our data access pattern. But if you've built applications in 7, you know that that sort of generic model of how you access data on the phone is pretty limited in terms of what you can actually access, right? So you can do Lync against object collections. So in-memory collections, you can filter and order and do all of those Lync operations, but only once they're in memory. And then you can do link against XML data sets, which is pretty useful for when you're dealing with web services, for example, where you're pulling down a chunk of XML from an HTTP service. You need to parse it, turn it into a set of objects, and then bind it to your data. So this enables a lot of scenarios, but it's still somewhat limited when you think about what the possibilities are with link. And so what we're doing in Mango is actually extending this out to 3 new data sets, or types of collections, if you will. The first is SQL, so we're going to talk about how you do link against a database. Second is user data. So as I mentioned, we're making contacts and appointments available from the phone. And the third one is OData, which, again, I'll check how many people are familiar with OData. Again, a good number of you. So again, OData is a way for you to expose your data collections from the cloud or from your enterprise as a simple, queryable interface from a client platform. This was something that you couldn't do easily in 7. We were missing some of the core frameworks required. But we've enabled those, and the OData team has actually done a lot of great work to make that possible. And so the demo I'm actually going to show is using an OData service to bring some data down to the client. So I want to talk through a couple of sort of example scenarios that we thought about when we were building our data access strategy for Windows Phone Mango. Now you're going to see that these scenarios do skew a little bit towards sort of the consumer application side. So they're the types of things that you'll see predominant in our current marketplace or in competitive marketplaces from a consumer application perspective. I think, though, if you look at sort of what the requirements of those applications are and kind of the types of scenarios that they're trying to achieve, you can map that pretty well to a bunch of business applications as well. So, clearly, Windows Phone is still primarily a consumer smartphone platform, but we're making bets to move more towards great enterprise support. But you'll see that these scenarios are a little bit more consumer focused. So the first one is just a simple shopping list application. So this is actually an app that we shipped from Microsoft as a sort of an example app in 7. And so it's something that it's possible to build with the existing platform. So you have your schema, you just create your objects, you serialize them out when the application ends, you write them to isolated storage. Next time the app starts up, you read them all in. You might do some intelligence there about when to read in certain files, slice and dice the data in certain ways. But it's more complicated than it really should be, right? You have to do a lot of work as a developer to make this scenario work, particularly as you add more features and your schema gets more complicated, or as you start to handle larger and larger data sets. So for users that are creating lots of lists, lots of items, making that a performant application becomes a little bit more difficult. So this is a scenario we wanted to make much easier in Mango. So whereas the shopping list was something that you could build in 7, but it was just, we think, a little bit too difficult. Something like a dictionary application where you wanted to have a large, local, offline reference database. If you think about a dictionary, on the order of, say, 500,000 entries, trying to do that with just, flat files and XML or even your own sort of custom serialization was a seriously tall order, right? You have to figure out how you want to split up that data set into smaller files. As the user does queries, you need to figure out which files you're going to read into memory and so on. And so this was, frankly, nearly impossible to do in a really performant, easy-to-use way in 7. So this is the type of scenario that just kind of cries out for a database, right? The third one is somewhere in between. So this is, in the dictionary case, you've got this requirement from a user perspective to have all of those 500,000 entries locally stored on the phone because you want to have that at your fingertips at all times, right? You want to have all of that data available, even if you're not connected to a network. You can just quickly look up a word and get the information you need. Most of the time, though, you don't actually want that, right? You have some large data set that is hosted up in the cloud, either in a service that you control or maybe in some third-party web service that you're using. And you want to be able to just kind of pick and choose data from that larger data set to bring down to the device and then mash up with user inputted data. And so an example of this is actually the demo that I'm going to show, where I'm using an OData service that's provided by wine.com that provides a huge catalog of bottles of wine that I can query against using OData, pull down to the device, store locally, and then mash up with some choices and interactions that I as a user perform. And so these are the types of scenarios that we're really moving towards on the phone, where you've got this kind of mix and match of cloud data plus local data. And we wanted to make that pretty easy to do. So those are primarily the database scenarios. The last one I want to talk about is the user data type scenarios. So if you've built applications in 7 that try to take advantage of some of the social capabilities of the phone, you'd probably be aware that there are a fairly limited set of things you can do, right? You can launch what we call a chooser, where you get basically the contacts list that's on the phone, and the user can pan through that, choose a contact, and you can get back either their name, their email address, or their phone number. So it's a fairly limited set of information that you get back. And you also, if you want to do that for multiple contacts in the address book, you have to call that multiple times. So it's not the greatest user experience. And so what you'd like to do is be able to programmatically access that full address book and do some interesting queries on it. So for example, take the full address book and get the list of people who have birthdays in the next month, right? So you can have an app that reminds you about birthdays that are coming up. And you can mash that up with some of the background capabilities that we're adding in Mango and create a nice sort of reminder service for your friends' birthdays. On the calendar side of the house, there's really nothing you can do in 7. There's no way to get access to any of the data that's in the calendar with the API set that we shipped in 7. And so scenarios like this, where I want to find an available time on the user's calendar to set up a meeting, there's really no way you can do that short of basically rolling your own integration with some cloud service, be it Facebook or Windows Live or what have you. And so we wanted to enable that on the phone. No, we'll get to that in a second. Okay. So before we go too far into the details, I just want to introduce the application that I'm going to be using for these demos. So like I said, this is an application that I built using an OData service that's provided by wine.com. So you can actually go out and use this today. It's in beta. And what I have here is a set of wines that I've actually chosen and downloaded locally into a SQL database on the phone. And so I've got a set of wines that I've got stored locally, and then I'm filtering them based on a set of criteria, right? So I've got the wines that I've got at home. I've got some that I've marked as favorites. I've got some that I've consumed recently. You can see that they're all from today. So I was just preparing for the talk, trying to loosen up a little bit. So I went through a couple of bottles. But I'm feeling good, so it's fine. And so, for people that aren't familiar with databases and with building these types of applications, you show them this, and you could potentially show them something that looks very similar, built in 7, right? And it's kind of difficult to make this type of scenario pop. But you can imagine people that have dealt with these types of scenarios before know that if I've got hundreds or even thousands of wines that I've downloaded locally into my store on the phone, then doing this, even this sort of simple type of user experience is pretty challenging, right? Because I want to be able to just take from that list of 1,000 wines the ones that I've got marked as currently being at home. And so if I'm going through an XML file, I basically have to read that XML file up into memory, crawl through it, and then display it. And I'm going to be loading potentially megabytes of data that I don't actually want to display in this experience. And so this is clearly the power of having a local database on the phone. And I think for most of the people in this room, you're kind of, you get it. But it's a sort of a subtle point sometimes compared to sort of more flashy features that this is something pretty powerful. So let me just show you quickly how I can add a new wine. So I've got a set of varietals that the OData service from wine.com supports, and I can go out and search for those, get some of these back, getting back images as well for the label. Tap on that guy, bring up a details view, and then I can add it to my cellar, or maybe add it as a favorite. And I'll show you later, basically how that's working in the code. But just a pretty simple user experience, and the type of thing that you would probably want to have on your phone to keep track of what you've got in your cellar at home. So you can see I added this Turnbull. And now it's showing up as at home. I can go back in here. Maybe after the talk, I'll go have another bottle and mark that as complete. There we go. And if I go back over here, we should see it in the recent. Somewhere, there it is. So what is that? 7 or 8 I'm up to today. Not bad. OK. So that's the basic idea. Oh, one more thing. So as I'm consuming these bottles and marking, the items that I've actually had previously, I can do interesting things like show statistics, right? So this is pretty basic sort of BI light kind of application where, as a true data geek, I'm going to keep track in a pie chart form of which wines I'm drinking, so that I can make sure that I'm getting equal balance between my Chardonnays and my Cabernets, because you don't want to overdo it too much. And so this is a good example of being able to take, again, the power of the database. So this is clearly a group by statement that I'm doing against the database, right? Grouping by particular varietal. And then I'm mashing that up with the Silverlight charting controls that you can easily import into your phone projects. And so this is just an example of how you can bring these two technologies together into some pretty interesting scenarios. So with that as background, let's dive into some of the details. So I want to put our database support in the context of data storage on the phone all up. So if you've built applications for 7, or for that matter for Silverlight, you're probably aware of isolated storage. So isolated storage is basically your sandboxed portion of the file system, right? So it's isolated from both other applications as well as from the rest of the system. So even the platform, apart from setting it up on installation, doesn't go and meddle with that storage. It's something that you've got sandboxed. In 7, there's 2 types of data that you can store in isolated storage. You can do basically a property bag type of data set using the isolated storage settings API, where you get effectively sort of a hash table, and you can set small bits of data in there. The platform will then serialize that down to a flat file for you. For larger data sets or data that you want to have more control over, you can just write your own flat files using standard sort of file I/O APIs. That's isolated storage. That's where we're going to be adding the ability to create a database file. So you can create a database file and have read-write access to it in isolated storage, effectively like any other file that's stored in isolated storage, but of course with all of the database niceties on top of it. But otherwise, it acts like any other file in isolated storage. The other place where you have data, which is a little bit more subtle, and generally people don't think about it, is what we call the application data folder. So you can think of this as basically the exploded contents of your application package. So when you create an application in Visual Studio, and you build it, you get a ZAP, which is just a zip file that has all of the resources for your application inside of it. And within that file, within that ZAP, you can have XML files, images, all different types of data. So what we're adding in Mango is the ability to have a database file prepackaged in that ZAP file. Yes. So the key about the application data folder is that all of that data is read-only. And the reason we do that basically is that the application data folder gets wiped out every time you do an update of the application. And so unlike isolated storage, which is persisted through updates, the application data folder is basically wiped out every single time. And so we keep this as sort of an invariant that the app data folder is always going to be read-only, and that way we don't get into any kind of hairy situations where developers are actually writing data in there, and then they do an update and it disappears, and now they're wondering where their data went. So that data is strictly read-only. Isolated storage is writable. And so I'm sure it's pretty obvious kind of how you would potentially use these. The app data folder is really for reference type databases, right? So if you think back to the dictionary example, you have 500,000 words. Generally, you're not going to allow the user to change the definition of the word in your dictionary. That's probably an interesting type of application, but the standard dictionary won't let you do that. And so you probably just want to keep that fairly large data set in the application data folder. And that way, when you update the application and maybe add the next set of words, you just wipe that out, get the new data, and the application can continue running just like it did before. Whereas in isolated storage, you're going to have more of user data and things that have been added at runtime. And you, as the application developer, are going to be responsible for moving that forward across versions.
Is there any performance difference depending on where you got that data from?
Nope. So in terms of architecture, how many people, I should have asked this earlier, how many people are familiar with LINQ to SQL? Okay, a good chunk of you. So this is not going to be too much of a surprise. But basically the architecture is, you've got your application at the top level. You're writing LINQ queries that are going against a data context, which is effectively a proxy for the database. And we'll talk about that in a little bit more detail. But these are the types of queries that you're writing in your application. These get translated down into expression trees, which are sort of this generic way of defining a query in LINQ. And those get parsed by the LINQ to SQL layer, which is in the system.data.link assembly. Ultimately, that all gets translated down into the SQL that we know and love and gets executed against a SQL compact database. So this is kind of the stack that you're looking at. Now you'll notice that the yellow box has the label Microsoft.phone.data.internal. The reason that there's an internal there is that your application is not actually talking to that assembly, strictly used by the platform from the LINQ to SQL layer. And actually, your application doesn't have the ability to talk directly to the SQL database. So this is one change from LINQ to SQL that people may be familiar with on the desktop, which is that we are strictly restricting access to the database on the phone to the LINQ to SQL API set. So you can't do raw execute command against the database. You can't get access to like ADO.NET data reader type objects. We've decided to keep it very strictly at the managed layer, sort of for consistency with the rest of the platform and for maintainability going forward. But I'd be curious to talk to people afterwards if there are any sort of concerns about that or scenarios that are impacted by that. So anytime you talk about an object relational mapping technology, which LINQ to SQL is, you've kind of got this debate about, do you create your database first and then sort of map it upwards into your objects, or you create your objects first and then map it downward into your relational database, right? And that's just kind of one of those religious debates that goes back and forth. We've taken the position that because you don't have any type of sort of legacy databases to support, and really you're writing your application from an object layer first kind of model, both today and going forward into Mango, that really the main way to use a database on Windows Phone should be writing your object layer first and then mapping that down into the database. And so what that means is that at design time, you're going to create your object model. So in the wine application, I might have varietals and wines and vineyards that are just POCOs, right? Plain old CLR objects that I've got in my object model. That in fact I might even have if I'd written this app in 7, same objects. And then I'm going to go through and decorate those objects with the appropriate attributes for persistence. So I'm going to tell the platform what's a table, what's a column, where are my primary keys, where are my associations, and so on. So that's really the work that you have to do above and beyond just defining your object model to persist the data in the database. So at runtime, you're going to take that object model and create a data context, which is, again is the sort of the proxy for the database in isolated storage, or in the in isolated storage in this case. And that's going to be your reference to the database. There's a single API which you call, which is called create database, which will actually take that object model, use the data context, and generate the underlying schema. So create the SQL compact database under the hood. When you actually have that database created, you're going to start to add data and modify data on the phone as part of your application. And so you'll make those changes to your object layer first, and then you'll use the submit changes API to actually persist that data down to the database. And we'll walk through some examples of that in code in a second. So that kind of gets you up and running with the V1 of your application. So now you've got your database going, you're doing queries, you're doing updates, you're making changes. Along the way, your users give you reviews, or in some cases, maybe your client asks you for some new feature, and so you need to be able to make changes to your database schema to account for that. Now, in LINQ to SQL on the desktop, you might go and just write some raw DDL to actually go in and add your columns or add the tables that you need to account for those changes and requirements. Since we're not enabling the ability to write that type of sort of opaque DDL down to the database, what we're doing is giving you managed APIs to be able to do those types of schema upgrades. So you have the ability to call .NET Managed APIs to add tables, columns, foreign keys, and indexes. And that's all transactionally handled by the platform with some support for versioning of your schema. And so I'll talk through that in a second. So I'm going to show a couple of bits of code on slides, and then I'm going to jump over to Visual Studio. But this is just kind of to isolate some of the things that you have to do as an application developer. So I talked about the data context. Again, it's the proxy for the database, where you're actually going to call out, OK, what are the tables in my object model, and how do I actually create this database? And then to your objects in your object model, you're going to add that attribute for marking things as tables, and then attributes for columns and primary keys and so on, as I mentioned. Once you've got that all defined, then you're going to create a data context, create an instance of your data context, give it the path to the location that you want to create it in, and then call that create database API. So if you'll notice that at the bottom of the screen, where I'm actually newing up the data context, there's this kind of funky isostore : WIMDB type syntax. If you remember back to the two locations where you can have data in your application, isolated storage and app data, we're using this URI scheme to differentiate between those two. So in this case, I want to create a read-write database in my isolated storage. So I'm going to use this isostore : terminology. If I wanted to reference a read-only database that I included in my ZAP package, I would use appdata : basically the same model, just changing that terminology. Very quickly on queries, same idea. You're going to new up a data context to get access to the database, and then you can just write standard LINQ. So if you're familiar with LINQ, but not LINQ to SQL, I think this is still going to look fairly familiar, with the one sort of difference that instead of querying against an object collection, you're querying against that data context, and specifically against a particular table within that data context. But otherwise, doing your standard LINQ operators will work fine. So that's queries. And for people, again, that have done LINQ but maybe not LINQ to SQL, that's not going to look too foreign. Obviously, LINQ is not really designed for doing inserts, updates, and deletes, right? It's about queries. And so LINQ to SQL has the added capability to add new data or modify data that you've got in your database. And so here again, it's all about that data context, right? The data context that is the proxy down to the database is really your portal down to your data that you can make changes to. And so everything you want to do against the database is going to go through that data context. If you want to add a new record, if you want to modify an existing record or delete a record, you're going to do that against the data context first, and then you'll submit those changes down to the database. It's kind of this two-step process. So we can walk through an example here, again, using my beloved wine app. So I'm going to do a query against the data context, which is going to call down into the database to get me back the list of Pinot Noirs that I've got at home, right? So you can see that I have pretty expensive tastes. I watched the movie Sideways and got really excited about Pinot Noir, but I only wanted to spend $5 on a bottle of wine. So I have my little penguin and yellowtail, and I think they taste pretty good. So now I go home and I have the little penguin. It's a lovely evening, and the next morning I want to take an inventory of the wine that I've consumed, as you do on your phone. Because you need to have that always up to date. So I go in and I mark it, is consumed, or I drank it, I think is the name of the button, and that's going to change the at-home field to false. And that, again, that's an operation that I'm doing against the object. So now that change that I've made is on that object mapped into that data context, but it's not yet in the database. So the key here is you've got to actually call the submit changes API, which will take those changes from the data context and submit them down. And you'll notice that nothing actually changed on the left side of the picture because I didn't make any modifications to the Yellowtail object, and so LINQ to SQL didn't actually take any of that and submit it down to the database. It only took the things that I've changed and submitted those. So a few examples of this in code. An insert is kind of exactly what you would expect. You're going to new up an object, set the properties of that object as you like them, and then you're going to use the insert on submit API to actually insert that into the data context and then submit it down. An update, you need to query it out from the database first, make the appropriate changes, and then again submit. Not too complicated. Finally, deletes, very similar to updates in the sense that you're going to query the items you want to delete first and then submit them to be deleted. The caveat here is that, of course, we're dealing with a database. You may have set up foreign key constraints on that database. Those will actually be enforced by LINQ to SQL. And so if you've got a foreign key relationship, in this case between your vineyards and your wines, and you go to try to delete all of the vineyards, then you're going to get an exception that says you can't actually delete this until you go and clean up the associated wines. And so this is one way to do it, where you actually just iterate through the list of wines for a particular vineyard and delete all of those. and then submit the changes. You can also set up cascading deletes if you want to have it taken care of automatically. So the interesting thing in this case is, while I'm doing a single submit changes to delete both the wines and the vineyards, LINQ to SQL will actually be smart enough to make sure that the order of those operations doesn't generate another foreign key exception. So, even though you're not doing those as separate transactions down to the database, we'll make sure that that everything goes through smoothly. Okay. So the last item I want to talk about on database support is the database schema upgrades that I talked about earlier. So again, we don't have the ability to do raw DDL, and so we're giving you the opportunity through managed APIs to actually do sort of the most common database upgrade scenarios. So again, add columns, add tables, add indexes, and add foreign keys. Some feedback that we actually got early on in our API review with a set of developers was, hey, we need to have the ability to version that schema, right? So we want to have some transactional way of marking what is the version that I'm updating to with these set of operations, these add operations that I'm doing. And so we have the ability for you to set a database version when you go to do that upgrade, and that will be submitted down to the database transactionally. And so it looks roughly like this. Sound like a broken record, but you're going to new up a data context, get a database schema updater object, which is available from an extension method off of data context. And in this case, you can check if the schema version is 1. If so, then I know that I need to upgrade to my V2 schema based on what I've got stored, or what I've got written in my object model. And I'm going to go and add a bottle type to my wine class. And then you'll see I'm setting the schema version there to 2, so that I know when I run again the next time that I don't need to redo the upgrade.
Quick question.
Yep.
The commit or the commit of the transaction, is this not mentioned on the page, or is it not necessary or not supported?
Sorry, that's what the execute API does. So yeah, whenever you're calling the managed APIs like add column, add table, and so on, nothing's happening in the database yet. So similar to the way that submit changes works for your sort of DML style operations, the execute API here works on the DDL side, right? So you're making changes purely in the managed layer, and then when you call execute, we'll actually batch up those changes and submit them down transactionally.
And what if a schema change, we will also need some data content change? Is this doable in one transaction?
So the question is, can you make content changes at the same time you're doing schema changes? No, you can't. So the only real content change is this schema version, which is a property that we're managing on your behalf. Otherwise, there's no way to combine a content change to some of your tables with a schema upgrade. So, good question. Yep.
So let's say a user skips one upgrade, like they go away from once and then one upgrade again.
Yep.
And I change my schema twice.
Yep.
So I can split another edit.
Yeah. So the question is, what happens if the user skips a particular version of your app, and so now the user's on version 1 and your object model is on version 3 instead of 2. And so yeah, the standard practice I think in that case is going to be you're going to in this case I've just got it all in one chunk of code, but most likely what you'll want to do is have maybe separate classes to do sort of your V1 to V2 upgrade and then your V2 to V3. And so you'll kind of see where your user is at and then just run them through those upgrades one by one, sort of like the database migration scripts. That run from the object level. I'm just going to hold that question. Good questions, but I'm going to try to make sure I make it through all the content, and then we'll take a bunch of questions at the end. I don't think they're going to kick us out of here. So let me just make sure I can breeze through the rest of the stuff I want to talk about first. So you've seen some PowerPoint code. PowerPoint code, as far as I know, still doesn't compile. So I'm going to switch to Visual Studio. And walk through a few things here. So I kind of skipped over some of the details of the OData support that we're adding in the phone, and that's deliberate. First of all, there's a lot of people here that are familiar with OData, and also there's really no changes from what OData supports in Silverlight on the desktop to what we're enabling on the phone. So you can today go out and look at the documentation for OData support in Silverlight, and you'll be all set to go on the phone. But I just want to kind of point out the power of what having OData on the phone gives you. So I actually wrote this application initially using Wine.com's REST API. And I've got it, that code if-def'd out. But you can kind of see here that it's a little hokey in terms of how you actually post that up to the REST service, right? You basically just have to create up your own URI scheme based on the query that the user wants to do, and mash that up into a string and send it off. Whereas when I get the response back from that REST API, I basically get a chunk of XML that I need to go do some linked XML queries against. So it works, but from a code readability and kind of ease of development standpoint, it's not the greatest. Whereas on the OData service, I can basically do link-style queries against the cloud, right? Which is pretty cool. I can order data, do filtering on data based on what the user has input, and that query is actually bundled up and sent off to the cloud service, and the query itself is done against the cloud, not locally on the phone. And when I get that data back, I get strongly typed objects that we can see over here. You can actually go take a look at in the object browser and see all the different objects that are supported. So if you're familiar with OData and adding a service reference to an OData service, all of that stuff works perfectly fine with the phone tools that we're shipping in Mango. So all of that experience you have there will carry over quite nicely. So that's OData. I want to walk through, within the context of this application, kind of how you set up the database. So again, the data context, I'm going to set up a set of tables for wines, vineyards, varietals, and what I call wine consumption instances, which are just for a particular bottle, having drunk it on a particular day. And then I have my constructor, which takes in a connection string. So each of those tables that I listed there in the data context has an associated entity that I need to define. And here I'm just doing what you would expect, right? The wine has a name, has a description, it has an image URI, a pointer to some image that is stored on the Wine.com service in the cloud. And I just need to decorate these properties of these objects appropriately with these column attributes to tell Link to SQL that these are meant to be columns in the database. Another thing that you would tend to do with raw DDL statements in Link to SQL on the desktop is set up indexes. So we've added an index attribute that you can set up on your class. And basically, it's just a delimited set of column names. So you can have one or more columns added to that index. And that'll speed up performance for queries against those particular columns. So that's all the sort of design time setup you need to do for the database. Now, at runtime, here I'm in my app.xaml.cs. And I've got a method that is for initializing when the app is either launched or activated. And I'm just going to check if the database exists and then go ahead and call it. And again, that's going to go through that data context object model, figure out what needs to be done, and create the appropriate schema. So now I've got my database. I'm going to want to do some queries against it to populate that sort of main page that had a few different filters of data And so I've got just a few standard queries here. In this case, I'm doing the query for the recent items. So I'm querying against the wine consumption instances table, checking for is consumed equals true, ordering that by the date, and projecting that out into a list, which you need to do in order to data bind against your controls. So that's one way of doing the query. It's a slightly less performant way because every time you run through this query, we need to regenerate the SQL statement to submit to the database. And so most likely, in most cases, you're going to want to use a compiled query, which will actually pre-compile the SQL statement. And every time you run through it, then you won't have to take that hit of actually recompiling it. And so you have to basically define a delegate for how you want to have that query executed, and then pass in the appropriate parameters. So that's all the querying. Now you've got the data somewhere on some background thread. You need to get it back up to the UI thread. Nothing too surprising here. Just as you would if you're querying data from a web service and taking link to XML to parse it apart, you're going to need to use a dispatcher to post it back up to the UI thread so that it shows up on screen. Finally, the statistics query that I showed is, like I said, just a simple group by where I'm grouping the list of wines that I've consumed by the varietal name and then mapping that into the Silverlight control. Okay. I want to walk through a few best practices that we're sort of building up over time with respect to how to use this on the phone. So there's Link to SQL is clear. It's a desktop technology that we've brought over to the phone. There's a bunch of best practices and documentation that you can find online for how to optimize your Link to SQL queries and set up your database and so on. There's a few things that you might want to think about in a little bit more depth when you try to do this in a phone application where you don't necessarily have the resources that you do on the desktop. The first one is think about the size of your change sets. So if anybody's watched my talk from Mix, where you probably noticed that there's a lot of repeated content, this is actually a change. So at Mix, I said keep your data sets small, right? With the idea being that you want to submit often to the database to avoid data loss, right? Because if you don't submit to the database, remember that the data is kept in that data context object. The user exits away from the application. If it doesn't make it down, then they run it again. The data's not going to be there. There's kind of a nuance to this, which is when you go to submit that data down to the database, it takes some time to actually write it out because we're making sure that we're actually flushing that down to the SD card. And so that write operation can take a little while. And so depending on your scenario, you're going to want to think about whether you batch up a larger set of changes to submit down and increase performance, but you're taking a little bit of a risk that you may lose data in that case, because if you have a huge change set that you want to try to submit down to the database when the user exits out of the application, you only have a certain period of time to actually run that operation, and so there's a higher probability that that data is going to be gone when the user runs the app the next time. And so the way to think about this really is if this is data that the user has entered into the application, and really your application and your storage is sort of the sole source of truth, then you're probably going to want to err on the write often side of the house, right? If it's the case like the wine.com app where I'm pulling a bunch of the content down from the cloud, maybe I want to err on the side of building up a larger batch to submit, because I can always go back out to the cloud to get that data again. And so it's just really dependent on your scenario. You're going to want to find the right balance for that. Use background threads, obviously. Link to SQL APIs are synchronous, and so anytime there's a synchronous API that can take a little while, you're going to want to run that on a background thread to keep the app nice and responsive. If you're doing read-only queries, like you're doing some sort of dashboard type application, sort of like the the Wine app that I showed, where that front page is really just a view, and you're not expecting the user to be able to make any changes from there. You can actually turn off the object tracking that Link to SQL does to enable writes back to the database. So if there's no chance that the user can actually make a change that writes back to the database, turn off object tracking, you'll get a nice little boost in terms of memory usage. For reference data tables, like the dictionary style application that I talked about, you're going to want to populate that in advance. I think this kind of goes without saying, that you don't want to have the user sit there while you pull dictionary.com 500,000 times to pull the words down. And so the brain dead simple, well, not simple, the best way to do this to ensure that the database is definitely going to be supported in your application is to create that database in a sort of simple project in the emulator, use a tool that we're going to ship with the Mango tools called the Isolated Storage Explorer, pull it out, put it into your package to ship into the marketplace. That way you guarantee that you're creating a database in the exact same format and runtime that your app is actually going to run on the phone. Now, the natural question that comes up in this context is, can I create the database on the desktop using desktop tools, put that into my package, and ship that on the phone? The answer there is kind of. Your mileage may vary. We haven't fully tested that. There are some areas that we know will not work. For example, if you encrypt your database on the desktop and bring that over to the phone, the encryption APIs are a little bit different, and so you'll not be able to open that database. There's a few other little things like that that we'll probably publish out as documentation or blog post so that people can get an idea of what we expect to break. But generally speaking, if you try it and it works, go for it. It will probably continue working, but it's just kind of a heads up that it hasn't been rigorously tested. You also want to think about kind of using the right tool for the job, right? So a database is really easy to use, and we think that the API set that we're shipping in Mango is something that's pretty simple to use. But if you have a pretty small data set, using a database to store it is going to be overkill. So the example I like to give is if you have a game that has a high scores list of 10 or 15 entries, creating a database to manage those 15 entries in a single table is not worth it. Right? You're going to load in a bunch of extra assemblies. You're going to take a little bit of an extra memory hit to manage those 15 items. Just create that in a list and put it in isolated storage settings, and you're done. It's just there's not enough data there to warrant actually bringing up the database. The last three I'm actually going to show a quick demo for. The Link to SQL offers the ability for a particular column to be marked as a version column, which allows us to figure out whether the changes that you're making to that particular record are working against the latest changes. And so the way this normally works in Link to SQL is if you make changes to your object, we make a copy of that object, and then when you go submit changes, we submit that as an update statement down through the SQL query processor to the database. And the SQL query processor is really the one that's responsible for figuring out whether there's going to be a conflict between your changes and changes that might have been made, in the case of the phone, on a separate thread, right? And so what we've done is actually enabled sort of a turbo path where we can skip that query processor altogether. But in order to do that, you need to set this version column, because that allows us to figure out from that single property on that object whether the object that we have in memory has changed outside of our knowing, and that can lead to a pretty dramatic performance improvement. Obviously, you're going to want to use secondary indexes for properties that you query pretty often, which is a standard database best practice. And finally, that should actually say iNotify property changing. So you want to implement the iNotify property changing interface, which is very similar to iNotify property changed that people may be familiar with from data binding in Silverlight. And what this does is when you do a query against a database, we materialize all of those objects up into memory, of course. If you plan to make changes to those objects, there's one of two ways that we can do it. we can either create second copies of all of those objects in anticipation that you might make a change, and then we've got an old version and a new version. If you implement the iNotify property changing interface, then we will actually wait until your object has been changed before we create that second copy. And so that can lead to a pretty significant memory reduction. So let me just quickly jump over to show this in action. Visual Studio running on the phone. How about that? Missed that session. There we go. Okay. So what I'm going to do is actually this button just populates a database with 1,000 entries, actually 2 tables, one sort of the slow table and one the fast table. But they're exactly the same data sets. And then I'm going to go through, when I click these update buttons, and do an update on 100 of the rows in that table. And so in the case of the slow update, I don't have the version column that I talked about. So let's see how long this takes. Okay, so almost 7 seconds. The fast update button has the version column, 9:54. So you can see with about 100 items update, which is a pretty reasonable change set for the phone, you're getting, like a 7x perf improvement just from that single version column. So that's one of the easier performance enhancements that you can do, and pretty dramatic. Index, well, fast is slower than. There we go. Click it enough times and it'll work. Indices are going to be a little bit more, hit and miss. This is probably too small of a data set to really make a difference because we're not, paging in enough pages. But as your data set grows, you're going to want to make sure you've got secondary indices. Let's look at the iNotify property changing case. So, whoa. All right, I'm not sure what's going on there. Let me try it on the phone. Sometimes the emulator can not be so great at emulating. So in this case, well, let's try it again just to see if we're, well. So first query with the waste memory button, about 700 kilobytes. The preserve memory button, 92 kilobytes. So that's, we're taking those objects and duplicating them, creating a bunch of extra change tracking before we even know that we need it. And so just by implementing that interface, we get pretty significant memory benefit that you can use to improve your app elsewhere without running into the 90 megabyte cap. Okay. So that's the database portion of the talk. I spent most of my time on that because I think that's what this audience is primarily interested in. But now I'm going to walk through the contacts and calendar API support that we're adding so you can get an idea of what we're doing there. So as I mentioned earlier, in 7, you've got the ability to get the email of a single contact from the address book or the phone number. But you have to do that one at a time if you want to get a bunch of different contacts. And these are the only 2 pieces of information you can get. We're adding one more flavor of this, however, which is that you can use the contact chooser to get the address of a particular contact. So this is actually pretty useful in combination with another capability that we're adding on the phone, which is the Bing Maps directions task. So you can imagine the standard scenario is You want to be able to choose a particular friend or family member from your contacts list, and then get that address and hand it off to Bing to actually get directions to their house. So in 7, you basically have to roll your own directions using the Bing API or some other web service. Now you can basically just take that address, pass it off to Bing, and get those directions. I think you actually get, that's a good question. Yeah, actually, yeah. If you choose somebody, so it's all implemented as part of the platform, right? The chooser. If you choose somebody that has multiple either email addresses or phone numbers, there's a second screen where you disambiguate, and the user says, okay, I want mobile or work or what have you. So that's the address chooser task. Pretty straightforward addition to those other two. And then the bigger change is that we're adding programmatic access to the contacts and appointments from the phone. So very quickly, the address chooser task, very, very similar to the phone number and email choosers. Basically, you new up an address chooser task, you create a completed event handler, and then you fire it off. When that'll hand off to the native experience to actually have the user go through and choose a particular contact, and then your app will get reinvoked with that data. Now, contacts and appointments. Before we go into the sort of the implementation details of it, there's two kind of major caveats to make up front. First one is that contacts and appointments are read-only. So you can query the address book and the calendar from the user's device. You cannot write back to those stores. And that is not a philosophical stand. That is a resource and schedule stand. And so this is a great example of where if you have scenarios where you want to be able to write back into these stores, we'd love to hear those because that's going to help us plan how we actually enable this. This was a case of, we didn't want to do this in a kind of really quick and dirty manner because this is sort of sacred data for the user, right? And so if you just give the ability for any manner of application to start writing in random contacts and properties and making changes, that very quickly degrades the user experience. So we wanted to be very careful to wait and do this right. And so it's critical that we understand the scenarios that you want to enable so that we can actually do it in the best way for you as a developer and for the user. The second key point is that third-party social network data that we've got integrated into the people experience on the phone is not shared with third-party applications. And this one is based on contractual obligations that we have with those partners. So for example, our contract with Facebook only allows us to really bring Facebook data into the people experience that's written by Microsoft. Does not allow us to turn around and give it out to third-party developers. Facebook would prefer you to do that through their APIs using OAuth, and so that they can track usage from actual third-party applications rather than going around the horn. So quick summary of the data that you get and the data that you don't get. There is a small nuance to the Facebook case. In Facebook, you can get the name and the contact picture, but nothing else. For the most part, with Exchange and Windows Live, you're going to get full contact details. Other social networks that we've got integrated into the People Hub, like Twitter, LinkedIn, and so on, are not available. Text messages, no. So think back, when I started the talk, I talked about link to SQL and link to user data as being kind of the two main points of discussion here. On the link to user data side, there's kind of a small wrinkle, which is that the address book functionality and the calendar functionality on the phone has been specifically optimized for a set of queries that the actual people experience does fairly often. And so for the most part, your applications are going to want to use this search async method which allows you to choose from a set of those predefined indexes. So you can query on name, email, or phone, and then pass in a filter expression to actually do that query, which is not a regular expression, just a straight-up string. And you can, like I said, choose the type of filter that you want. The nice thing here is that we are exposing the pin to start property. So pin to start is sort of this unique concept on Windows Phone where you can choose a contact from the people experience and have them show up on the start screen. What you probably want to use this for in your applications is as kind of a proxy for favorite contacts, right? If the user has set a bunch of contacts to their start screen, those are probably the people that they want to keep in touch with most often. And so you can use that within your application to demonstrate favorites. So yeah, an example of using this search async method, I want to search for people whose name includes JA, and I can fire that off. I'll get a response back on the UI thread, which has basically an IEnumerable collection of the contacts that I get back. Appointments is going to work in a very similar fashion. Again, you've got a search async method, and in this case, I want to set a window for the calendar that I want to search on. So this is, in an address book, there's a finite number of contacts. In a calendar, it goes on forever, or maybe till Saturday, depending on which particular apocalyptic story you believe. But Windows Phone Mango is set up to handle if we make it past Saturday. So in this case, I'm querying for now to a week from now, and I can set a list of the maximum items to return. So if I just want to find, a single item, I can set that. Or if I want to get, a set of appointments back, I can do that as well. And again, in both of these cases, I've got this state variable, which if people are familiar with the HTTP web request API for doing web service interaction, this model will look very familiar. This is basically the ability for when you're doing an async method to have state that kind of travels with that, so that when you get called back from that async method, you can take that state and use it to continue on with your operations. So standard use of that is you've got some actions that you've set up to call back once you complete processing this information. You can keep the pointers to those actions within that state property bag. So a few sort of performance and best practices tips on the contacts and calendar APIs. The first one is more of a user experience type thing. So we are going to have a capability, which if people are familiar with capabilities on Windows Phone, basically it's when you go into the marketplace, you look at a particular application, you can see this application requires access to your location, it requires access to the network, the camera. There's a series of things that we indicate to the user this application is going to use. So before they download it, they can decide whether they actually want to enable that application to use those things. We are going to enable similar capabilities for contacts and calendar information. So you will see that in the marketplace if your application is using those APIs. But we kind of want developers to go above and beyond that, right? Because it's one thing to say, okay, I'm going to give access to this application to use my contacts and calendar information from my phone, but I would also kind of like to know what they're going to do with it, right? So, provide either as, you don't have to write a huge EULA into your application that explains in tremendous detail how you're using the data, but just kind of make it very clear why you're accessing the user's contacts and calendar information and how you're using it, just so that it's very upfront to the user. You will run into fairly large contact lists, and so when we're doing a query against a giant address book database, it's going to take a few seconds for that to come back. It is happening on a background thread, so your app should continue to be responsive, but you're going to want to be cognizant of that in your UI that provides some kind of loading screen or some indication to the user that it's taking a little while for that data to come back so that they don't just navigate away. And finally, the data that you're getting back from these APIs is a point in time. So if you have a case where you do a query against the contacts or calendar databases on the phone, the user navigates away, you get either tombstoned or fast application switched and sort of just paused, and then the user comes back, say 10 minutes later. If you think of that data as being, the time sensitiveness of that data as being important, then you're probably going to want to requery when the user reactivates your application, because the data that you're going to have is basically an in-memory point-in-time collection, and not something that's getting updated dynamically. So I'm going to do one quick demo of contacts and calendar, and then we can move into questions. Do this one on the device. Well, I'm not looking at this screen anyway. So let's go over here. So one of the features that we've got available is to plan a wine tasting. So tricky to see, but basically I've got the ability to choose the date and time of that tasting. So I'm going to select this when here. And here we've got actually a couple of early controls from our partners at Telerik. So Telerik builds Silverlight controls and others, and they're building some controls that will take advantage of these contacts and calendar APIs on the phone. We expect more controls from other vendors to come out. And so what they've done is basically emulate the date and time pickers that we have in the native experience, but they augment it with information that they're getting back from the address book, or in this case, the appointments, the calendar. So you can see kind of in the top right corner of the day there that it's got a little gleam that shows a 2, which means that I've got 2 appointments today. And so you can imagine, I don't have very many appointments on this phone, but I could pan through here and get an idea of, okay, when is a good day going to be when I have maybe 1 or 2 appointments instead of 10. But I'm pretty confident that that today is going to be a good day to have a wine tasting, and I'm going to want to have a drink after this. And so I'm going to go in here and choose a time. So now I can drill down into specific hours when this might be a good time to set it up. So 6 p.m. is not going to be good because I'm still going to be here. 7, how about 8 o'clock? Okay, so 8 o'clock looks good, so I'm just going to snap that back to 8 p.m. to set that up like that. Yeah. Apologies for the overhead. But trust me, it's got the date and time there. And then I'm going to choose a place. And so in this case, I'm using the address chooser. So I tap on this little button, and I'm going to get the inbox chooser experience. So again, very similar to what we have in 7 for email and phone number. But in this case, I'm going to get back an address. So I'm going to choose, let's see, Andrew, who apparently lives at Microsoft. And then I'm going to choose the set of users that I want to have come to the wine tasting. So this particular control is actually something that's completely homegrown. It's not part of any toolkit that we're going to ship. This is purely a kind of a proof of concept for these APIs. And it provides a multi-contact chooser. So whereas previously when I was choosing the address, I could only pick one contact, this allows me to choose multiple. So I can go through and tap and select these folks. And then I get back not only their name and email address and all that information, but I can actually get back the photo that I have for that particular person in the address book. So I can create these kind of rich user experiences, lighting up my UI with the contact photo that I've got in my address book. So now I've got that all set up. I've chosen a time and a place and the set of people that I want to have come to the party. I'm just going to choose the send email task. I'm going to take those email addresses that I got back from those contacts, put a little bit of information, including the address, the date and time, and then I'm going to fire that off. And so now we've got a wine tasting set up for 8 p.m. this evening. And that's it. So thanks very much for attending this talk and for coming to TechEd. And again, huge thanks for supporting the platform and supporting the phone. And I can't stress enough how important your feedback is. We've been trying to collect all week requirements and scenarios for enterprise applications. We think that by adding, in particular, the database support to Mango, we're knocking down one of the big hurdles. We really want to understand what's the next set of things that we really need to go knock down. And if we can have those as prioritized lists from you, for your applications, for your clients, it's really going to help us build the next version of Windows Phone that we're planning right now. So thanks very much. Okay, so now I get to give away a free phone, and then we'll go to questions. So I think I'm meant to just ask a trivia question. So let me see. Can anybody name one of the best practices that I talked about for database? Yep.
Use background threads.
All right. Come on up. You just put your contact information on that and then give it back to me. Other thing is a bunch of resources. Please fill out your evaluation forms. You can scan this tag to